Good morning, students. Today I am going to explain the other remaining terms of chapter 6 Thermodynamics. In the previous video we have discussed about system, surrounding, then types of system, open, close, isolated system. Then we have discussed about the state of system and state variables. Now today I am going to start the next basic term called as the state function. Next term is the state function. So what is a state function? State function is a physical quantity. State function is a physical quantity whose values depend only on the state of system. It is a physical quantity whose values depend on the state of the system. State of the system means it does not depend on the path. It will depends on the state of the system, that is the initial and the final state, and these values do not depend on path followed by the system. These values or this state function does not depend on the path followed by the system in achieving this initial to final state. Clear? For example, a person is standing on the roof of a 5-story building. Suppose this is a 5-story building. A person is standing here on the top at a particular height, and here the person possesses a fixed value of potential energy. Here the value of potential energy is now fixed. Now this energy will not depend on the path followed by the person, whether he comes to this top of the building by using lift or by using stairs. So in this case the potential energy of a person is state function. Now here this potential energy is a state function. On the other hand, the work done by the legs of the person, जैसे वो जिस भी प्रोसेस के थ्रू वो ऊपर आया है, ठीक है. So in that case the work done by the legs of the person to reach the same height is not same in the two cases. If he uses the lift, in that case work done by his legs will be less. If he uses stairs to come to the top, in this case work done will be more as compared to the lift. So now in this case work is totally different in both the cases, hence this work is not a state function. तो इस work को हम state function consider नहीं करते. Clear? So sometimes we can call it as a path system. This work is also called as path system. So state function is that physical quantity whose values depends on the state of system, initial to final state, and does not depend on the path followed. Clear? Example, person in the 5-story building have fixed potential energy, therefore this potential energy is now fixed. It will act as a state function, and he reaches here either by using lift or by using stairs. So the work done in both the cases is not same, therefore this work is not a state function, it is called as a path function. Clear? State function नहीं consider करते इसको, हम simple क्या बोलेंगे, it is a path function. Now some physical quantities are also there which act as a state function, such as pressure, volume, temperature, internal energy, then enthalpy, delta H, entropy, delta H. Simple H ही बोल सकते हैं. Delta H means change in enthalpy. We consider here only H and S. Next is free energy, that is called as G. All these terms are called as state function. Clear? Now volume is also a state function. Volume भी क्या है हमारा? Volume is also a state function. How volume is state function? It can be explained by taking an example of water in a pond. Suppose हमारे पास एक pond है. This pond has water in it. Now the change in volume of water in a pond is not depend on the path followed by water, or it is independent of the route by which water is filled. इस पॉन्ड के अंदर वाटर हमने कैसे फिल किया है, किस सोर्स के थ्रू फिल किया है, बाय रेन, बाय ट्यूबवेल और बाय एनी अदर सोर्स और बाय बोथ. तो उस केस में हमें सिर्फ क्या चेक करना है कि इसके अंदर वाटर है. इनिशियल स्टेट वाटर नहीं है, फाइनल स्टेट वाटर है. किस रूट के थ्रू या किस पाथ के थ्रू इसको इसके अंदर ऐड करवाया डाला है, इट विल नॉट डिपेंड ऑन द पाथ. क्लियर? सो volume is, now when water is filled in this case, we will notice its volume. So volume is a state function. Clear? By which method और by which way water is added to it, that will not a state function, वो हमारा इसके केस में path function होगा. Clear? Similarly, temperature is also a state function. Temperature भी क्या है? State function है, because it does not allow matter how temperature can be attained. मैटर को टेम्परेचर कैसे मिला है, मैटर को अलाउ नहीं करने देगा. ठीक है, आइदर बाय हीटिंग और बाय कूलिंग, वो अलग फैक्टर है. ठीक है, उसको हम पाथ बोलते हैं. तो इस केस में जो कंडीशंस हैं, दैट विल डिपेंड्स ऑन इनिशियल टेम्परेचर T1 और फाइनल टेम्परेचर T2. वो इनिशियल स्टेट T1 से T2 कैसे आया, कूलिंग से आया, हीटिंग से आया है, वो पाथ फंक्शन होगा, वो स्टेट फंक्शन नहीं होगा. नेक्स्ट प्रॉपर्टीज़ मैक्रोस्कोपिक प्रॉपर्टीज़ or the macroscopic system. Next is macroscopic system and macroscopic properties, also named as, or also it can be classified into two properties, extensive and intensive. So first of all, we will start about macroscopic system. Macroscopic means the system, or the word macroscopic word implies to large quantities. This word is implies to large quantities. So in this case, if a system consists of large number of atoms, ions or molecules, these are the chemical spaces. These atom, ions or the molecules, these are the chemical spaces, and these chemical spaces will constitute the macroscopic system. So simply, the macroscopic implies to large quantity. Now we are doing about thermodynamics. We are studying about thermodynamics. So thermodynamics deals only with matter in the bulk. Clear? This thermodynamics deals with matter in the bulk. It doesn't deals with individual properties of the matter. So thermodynamics is that branch of science which deals with properties of matter in the bulk. मीन्स जो जितनी भी लार्ज प्रॉपर्टीज़ हैं, जितनी भी सारे प्रॉपर्टीज़ हैं, उनके साथ ये डील करता है, उन्हीं के साथ ये रिएक्शन शो करता है. एंड इट डज़ नॉट डील with the individual properties of matter. It doesn't deals with the individual properties like individual atoms और individual molecules. इनके साथ यहाँ पर chemical reactions में observation thermodynamics की हेल्प से क्लियर नहीं होती है. Therefore thermodynamics deals only with properties of matter in the bulk, and such properties are named as temperature, pressure, volume, melting point, boiling point, etc. All these properties constitute the macroscopic properties or the thermodynamics properties, because these property deals with matter in the bulk. Now these properties are of two types. First is called as extensive property and second is called as intensive properties. These macroscopic properties are of two types. First is called as extensive and second is called as intensive. Extensive properties are those which depend on, these are the properties which depend on the quantity of matter. These properties depend on quantity of matter, whereas the intensive properties are those which depend only on the nature of substance. These property depends on nature of substance and does not depend on quantity of the matter. क्वांटिटी के ऊपर ये प्रॉपर्टीज़ डिपेंड नहीं करती, लेकिन ये प्रॉपर्टीज़ किसके ऊपर डिपेंड करती हैं? सब्सटेंस के नेचर पे. नाउ इन एक्सटेंसिव प्रॉपर्टीज़, as we know, these property depends on the quantity of matter that is contained in a system. किस सिस्टम के अंदर क्या मैटर हमने लिया है, क्या उसकी क्वांटिटी है, that is called as extensive properties contained in a system. System is a part of universe taken for thermodynamic consideration. Clear? Now in this case, it was observed that properties like mass, volume and the heat capacity is the amount of heat required to convert given substance into its रेस्पेक्टिव फॉर्म, सॉलिड टू लिक्विड, लिक्विड टू गैस. मतलब जो भी मैटर की स्टेट के अंदर चेंजेस आते हैं वो हीट की वजह से आते हैं. तो मास, वॉल्यूम, हीट कैपेसिटी, ऑल दिस प्रॉपर्टीज आर कॉल्ड एज एक्सटेंसिव प्रॉपर्टीज. बिसाइड दिस देयर आर सम अदर प्रॉपर्टीज लाइक internal energy, entropy, enthalpy. S stands for entropy, H stands for enthalpy. Gives free energy, G. All these properties are extensive properties because the total value of extensive property is equal to sum of the values of the separate parts. जो भी हमारे पास एक्सटेंसिव वैल्यू की प्रॉपर्टी आती है वो किसका सम होती है? दैट इज़ अ सम ऑफ ऑल द सेपरेट पार्ट्स ऑफ द सिस्टम. क्लियर? नाउ intensive properties examples are such as temperature, pressure, then density, refractive index. refractive index को हम शो करते हैं म्यू से. ठीक है. viscosity, viscosity is the net resistance in flow of liquid. next is surface tension, surface tension, viscosity. ये टर्म्स हमारे चैप्टर 5 में आ चुकी है. नेक्स्ट इज़ द स्पेसिफिक हीट, नेक्स्ट इज़ द स्पेसिफिक हीट, देन फ्रीजिंग पॉइंट, melting point, boiling point, EMF of the cell, pH of solution. All these properties, mole fraction, molarity, all these terms are intensive properties. Clear? Now pressure, temperature are intensive properties. Here we have studied that pressure and temperature are intensive properties because these properties are independent of quantity of the matter in the system. सिस्टम की क्वांटिटी के ऊपर डिपेंड नहीं करता. सो दे आर फ्रिक्वेंटली यूज एज अ वेरिएबल टू डिस्क्राइब द स्टेट ऑफ सिस्टम. तो इन वेरिएबल्स को हम यूज़ कर सकते हैं स्टेट वेरिएबल की फॉर्म में ताकि हम सिस्टम की स्टेट को डिफाइन कर सकें कि उसकी फिजिकल स्टेट क्या है, हीटिंग से क्या इफेक्ट आया फिजिकल स्टेट, प्रेशर अप्लाई करने से क्या उसकी स्टेट के ऊपर इफेक्ट आया. क्लियर? नाउ इट इज़ ऑल्सो ऑब्जर्व दैट टू एक्सटेंसिव प्रॉपर्टीज आर टेकन. सपोज वी हैव टेकन एक्सटेंसिव प्रॉपर्टीज. Now it was observed that ratio of extensive properties was found to be intensive property. अगर हमारे पास दो एक्सटेंसिव प्रॉपर्टीज़ हैं, सपोज वी हैव टेकन मास विद रिस्पेक्ट टू वॉल्यूम. द रेशियो ऑफ मास वाज बाय वॉल्यूम इज इक्वल टू डेंसिटी एंड इट वाज फाउंड दैट दिस डेंसिटी इज intensive properties. It will depends only on the nature, not on the quantity of matter. Clear? So डेंसिटी एंड स्पेसिफिक वॉल्यूम. नेक्स्ट इज डेंसिटी. सेकेंड टर्म जो हम यहाँ पर यूज़ करेंगे इंटेंसिव प्रॉपर्टी के लिए दैट इज स्पेसिफिक वॉल्यूम. स्पेसिफिक वॉल्यूम इज आल्सो इंटेंसिव प्रॉपर्टीज. स्पेसिफिक वॉल्यूम इज डिफाइंड एज वॉल्यूम प्रेजेंट पर यूनिट मास. एंड व्हाट इज डेंसिटी? डेंसिटी इज अ रेशियो ऑफ मास बाय वॉल्यूम. ये दोनों में डिफरेंस है. डेंसिटी इज रेशियो ऑफ मास बाय वॉल्यूम एंड स्पेसिफिक वॉल्यूम इज द वॉल्यूम present in the given unit mass. So these are the intensive properties. Similarly, heat capacity we have discussed here. Heat capacity is also extensive properties. It is extensive property. But अगर इसके अमाउंट फिक्स कर देते हैं, ठीक है, तो उस केस में क्वांटिटी के ऊपर डिपेंड करेगा. दैट इज़ कॉल्ड एज extensive property. But if specific heat is taken, if we have taken the specific heat, then it will act as intensive properties. इसको हम क्या बोलेंगे? Intensive property. So overall we can explain that ratio of two extensive properties always equal to intensive properties. Clear? Next is force. Force is also extensive property and force per unit area. Force per unit area is equal to pressure. Now this pressure is intensive properties because force is extensive and ratio of extensive properties always equal to intensive properties. Clear? Next is thermodynamic equilibrium. Next term is sixth called thermodynamic equilibrium. How this equilibrium is attained? Equilibrium is attained when rate of reactant to product formation and rate of product to reactant formation becomes equal. In that case, the system is said to be in equilibrium. Clear? Now, a system is said to be in thermodynamic equilibrium if the macroscopic properties, which properties? Macroscopic properties, both intensive as well as extensive properties. इसके अंदर सारी properties आ जाएंगी such as temperature, pressure, etc. वॉल्यूम, मेल्टिंग पॉइंट, बॉइलिंग पॉइंट, जो भी प्रॉपर्टी हम कंसिडर करते हैं एक्सटेंसिव एज वेल एज इंटेंसिव. नाउ द प्रोसेस इन विच थर्मोडायनेमिक कंसिडरेशन and the macroscopic properties such as temperature, pressure, etc. do not change with time. Do not change with time. अगर हमारी मैक्रोस्कोपिक प्रॉपर्टी चेंज नहीं होती हैं, इट मीन्स इन दैट केस वी कैन से दैट द सिस्टम इज़ इन इक्विलिब्रियम. नाउ नेक्स्ट इज thermodynamic process. Next is thermodynamic process. Thermodynamic process is said to occur when a system changes from initial state to final state. It will occur when the system changes from initial to the final state. Such processes are called as isothermal process. For example, when a process occurs, in that case heat can flow from सिस्टम टू द सराउंडिंग. अगर हमारे पास कोई भी प्रोसेस थर्मोडायनेमिक्स प्रोसेस अगर टेक्स प्लेस होता है तो उस केस में हमने क्या ऑब्ज़र्व किया है कि जो उसकी हीट है, हीट का फ्लो होता है सिस्टम से सराउंडिंग में. इट मीन्स जो हीट हमने देखी है वो सिस्टम से बाहर किसकी तरफ इवॉल्व होती है, सराउंडिंग. इन दैट केस प्रोसेस इज सेड टू बी एक्सोथर्मिक इन नेचर. रिवर्स कैन ऑल्सो टेक्स प्लेस. द हीट कैन बी ट्रांसफर फ्रॉम सराउंडिंग टू द सिस्टम. तो उस केस में प्रोसेस हमारा कैसा हो जाएगा, एंडोथर्मिक. दिस चेंजेस टेक्स प्लेस व्हेन टेम्परेचर इज़ केप्ट कांस्टेंट. अगर हम ये हीट चेंज ऑब्जर्व करते हैं तो उस केस में हमारे पास 4 डिफरेंट ऑब्जर्वेशन आएंगी. फर्स्ट केस व्हेन टेम्परेचर रिमेन्स कांस्टेंट, सेकंड केस व्हेन प्रेशर रिमेन्स कांस्टेंट, थर्ड केस व्हेन वॉल्यूम ऑफ द सिस्टम केप्ट कांस्टेंट, एंड फोर्थ केस हीट चेंज टेक्स प्लेस is kept constant, यानी कि in which no flows heat from system to surrounding, in which there is no flow of heat from system to the surrounding. तो इन 4 पॉइंट्स को हम एक्सप्लेन करते हैं. टेम्परेचर इज केप्ट कांस्टेंट, दैट प्रोसेस इज कॉल्ड एज आइसोथर्मल प्रोसेस. इफ द टेम्परेचर इज केप्ट कांस्टेंट द प्रोसेस इज सेड टू बी आइसोथर्मल इन नेचर. क्लियर. व्हेन प्रेशर इज केप्ट कांस्टेंट with respect to the system, or we can say that it is a process during which pressure of the system is kept constant, that is called as isobaric process. Or volume constant is called as isochoric, and in which no transfer of heat takes place from system to surrounding, that is called as adiabatic process. उसका नाम क्या होगा, adiabatic process. So it can be explained, these 4 observation can be explained graphically as when the graph is plotted between pressure and volume. Suppose if the reaction takes place at constant pressure, तो हमारे पास ग्राफ का स्लोप इस तरह से आएगा. Therefore this slope is for constant pressure isobaric. If volume is kept constant, तो हमारे पास स्लोप इस तरह से आएगा. This indicate isochoric process. If temperature is kept constant, in that case with decrease in pressure volume of the system increases, therefore slope of such type is obtained, it is called as isothermal process. Next, when volume is kept constant, in that case it was observed that slope of such type is obtained. Sorry, this is for heat change when no flow of heat takes place from system to surrounding. तो हमारे पास स्लोप जो है वो आइसोथर्मल के जैसे आएगा, लेकिन थोड़ा सा उसके अंदर वेरिएशन आ जाएंगे. दिस इज़ द प्लॉट फॉर एडियाबैटिक प्रोसेस. One more point is that this adiabatic process takes place when the walls of container are insulating. Adiabatic process takes place when the system is completely insulated from the surrounding. Surrounding के साथ सिस्टम का हीट का, एनर्जी का, मैटर का कोई भी एक्सचेंज पॉसिबल नहीं होगा. क्लियर है. तो उस टाइप की वाल्स को हम बोलते हैं एडियाबैटिक वॉल्स, एंड दैट सिस्टम इज कॉल्ड एज एडियाबैटिक सिस्टम. सच टाइप ऑफ कंटेनर इज कॉल्ड एज एडियाबैटिक. नेक्स्ट है isothermal. In this case this process takes place in open system. It means it will have conducting walls. तो इसकी जो सिस्टम की वॉल्स होंगी वो कैसी होंगी, कंडक्टिंग, which can exchange both matter as well as energy with the surroundings. So in this container which have conducting walls, such type of container is called as diathermic. यहाँ पर हम इसके लिए क्या वर्ड यूज़ करेंगे, the system which possess conducting walls is said to be diathermic in nature, and the walls are called as diathermic walls. Clear.